Hey everybody, welcome back to Convince Tech, where on today's episode we are talking about a battery monitor for our ammo box battery backup. Now, what's so special about this is it actually does have a shunt built into the inside of the box that will track the current and will show the discharge or the watt hours spent from the battery, so you can actually see how much is left without having to guess just based on the voltage. Because as you know, as we've talked before, those voltage indicators, like what's here on the USB or on some of those state of charge indicators, don't really give you a good understanding of what a lithium iron phosphate battery is because of that flat charge curve or the flat discharge curve. So what we'll do today is a full end-to-end how to actually install this in the box, how to wire it up, do exactly what's needed, and then we'll give you the details on it here towards the end. So let's get started. All right, next up, we're actually going to be putting this monitor screen for the shunt directly here on the top of the actual box. Initially, when I thought about where I would be placing this, I had actually believed I could fit it either on the front side in with either where my 12-volt socket would be or on one of the actual ends here, so that way even if it's sitting up, you would be able to see it better. But ultimately what I came to is with how the wiring goes into these terminal pieces here, even if you use one of the ferrule caps and I actually have it stuck in, what that would mean is this would have some very sharp turns. So if it's actually on one of the ends, I would have to have this coming out at a very sharp 90, coming to wherever the shunt's going to be placed or out to the battery, which my battery terminals actually are the F2 style, of course, as you've seen, that sit here towards the front of the opening. So because I didn't want it that sharp, or I didn't want it here that's too low, because the battery, the new one that I have, when I went to the 18 amp hour, it's not this skinny one. It does take up the entire width of the box. I would have to actually be able to shift it higher, which this size doesn't leave enough room for. So what I'm actually going to do is I will be placing it right here on the top, so that way then I can still contain all of my wiring and it should function correctly. So let's go ahead and mark it out. All right, as you can see, I have it actually marked out. I did use this back side. If you notice, it has the flange on the front or the lip. You want to make sure you don't flip it upside down and measure against that, or if you cut the hole out to that width, the whole thing would just fall in and out. So what we do want to do is measure it to make sure that it fits directly to here. Now recognize there is this little clasp that when it recesses in, that's what should hold or retain this back, but it has a very limited thickness that will actually work for it. So we're gonna make it very tight up against here. We're gonna actually work that in if needed, give a little bit of extra clearance on the edge. If it ends up being too thin of or too thick of a box for this to work, we will probably add a bit of hot glue or something similar to actually hold this in longer term. But I'm not trying to be perfect. If you really want it to be exactly centered or where you want it, make sure you do actually measure it out, center it, adjust for the length and the width there. I eyeballed it. I believe it to be pretty close and good enough for my purposes. And so next we're going to actually be drilling it out. What I have is just a Dremel type tool with the adjustable arm and one of these cutoff wheels. That's what I will be actually cutting straight through this plastic on, turning it, making sure I actually hit all four sides. And once I have that out, what I will need to do is make sure some of this bracing behind will actually be cleared. As you've seen in my videos on the backgrounds, I do have some woodworking tools from some of my other hobbies, so I will probably more than likely be using a chisel or something similar. A pair of scissors or other types of like a razor blade potentially could cut through this plastic without too much fuss. So whatever works for you, we will need to get out some of this to make sure you have spacing for the wiring, as we mentioned earlier, to make sure that it can actually run everywhere it needs to. So let's cut it out. All right, that's all 4 sides, but next up we need to actually flip it upside down and see those bracers that's still going to be holding it on. So as you can see here, the main middle beam is actually what's still connected for this, even though I've pretty much cut out the entire exterior. So next up we're going to cut down through this beam, and actually I'm going to cut it almost at an angle, so that way when this goes in it's not going to be grabbing on these sides either. So I want to ensure that it's cut at that angle. All right, that's enough of the actual cutoff tool. Next, we'll probably end up cleaning it up with the chisel once we get this last little bit out. So as you can see, there's the main cover. And if we were to flip it over, it's not the cleanest thing, but with just a bit of cleanup, it should be good enough to fit in. So next, we're actually just going to be having to test fit it to ensure, are there any spaces that need to be cleaned or actually expanded to ensure that it'll fit in cleanly. Just like this little nib you see sticking out, we will need to take that off to make sure it's actually not catching on the actual device. All right, next up, we're going to want to try to test fit this in to actually see if it works or if we're going to need to expand any of the sides. So first, what I actually will try and do is tilt in one edge to test the side to side. So that does look like it works. And if I push it all the way to the end, I know that end works and will recess fine, which is good. Next, we'll try this one. And it does look like it's limiting us. So I can actually see a bit of my mark here and just a bit of cleanup needed there. So I'm going to come back with a chisel, try and straighten this up a bit. Even though I can force it in, I want it to be a bit better off, and then we will test fit one more time. All right, let's try it again. As you can see, it does take some back and forth effort here to ensure that it's perfect. And by perfect, I don't mean that it has to be exact, but what I do mean is you can't ever go back and add in more plastic. So if we cut too far and then it ends up falling in and out all the time, that would be a pain as well. So we want it to fit snug, just like this. So that way when we actually press all the way through, it snaps in and it would actually hold inside of here. All right, so as you see, we will do just a bit more cleanup because as I mentioned, there is this nib that I referenced in the beginning that is not actually fitting through. So we can do one of two things. We can cut out just a bit more of a hair to allow that nib to snap in, or we will end up doing something to actually hold it in permanent, that it'll go through. But before we worry about the finalized fitting of this side, what we do want to look at is how is our wiring going to work? So what else are we going to have to cut out of this lid? And the next big pieces that I can see is definitely this piece here, because we will want some wires to be able to come in and out straight. Secondly, we'll probably want to take off a bit of this piece here as well. As you can see, it does stand up pretty high and could get in the way of our first terminal there. And then lastly, what we will end up doing next is actually making a spot for the shunt to rest. So we're going to inset these just a bit and actually create some holes that we'll be able to strap in that shunt. What I'm going to use is zip ties. The shunt that I have, as you saw, does not have a backing to it. And I am going to be running low amperage through this thing, so I'm not concerned about too much heat being generated. Do it at your own risk, however you want to mount your system that you know would work for your needs and your usage. All right, if you'll notice here, I've actually cut those back. I might end up having to cut this fin back just a bit more. I'll probably go ahead and do that just from how it looks like it's almost in line there. Otherwise, I do think that I actually have a straight path that these can come out, and I know that this little piece won't get in the way either. And so let's go ahead and clean that one up now, and then we'll be done with the screen portion. we're pretty much done with the monitor top that you see, or the screen for the monitor. It does look like it still needs a bit of help ensuring that it's actually popping all the way through, so I'll probably scour that out just a bit more, because if you notice, you can actually still see that nib popping through. Otherwise, on the back side, that is now finished, so we can proceed with getting ready for the actual shunt on this side, and then we will be able to begin wiring it up and testing it out. Now we're going to be making a spot in the lid here for the actual shunt to be sitting in. So what I'm thinking now is I'm going to actually make a little recessed area, and then I'm going to cut some holes here to put some zip ties through, and I'm going to actually make like kind of braces here that will hold it together. So ultimately I'm going to put 4 holes, 2 on either side of this side panel piece here, and then I'm going to make a recess so that the actual shunt sits flat directly into it. Again, this one doesn't actually have some sort of backer board or, plastic or wood or fiberglass, something that's actually resting in with mounting holes. This is only containing the actual 4 screws that you actually do have to use when using the shunt. So instead of making some other backer board for it, what I'm actually going to do is just recess this here, hold it down with some zip ties. I do think it'll be quite sturdy, especially for what I'll be using it for. And then I will be running the wires directly from here, routing them over into here, and then a couple wires, of course. One, especially from this side, will be running directly into the battery. And then one here, my positive lead, I actually think it's this one here. The positive lead directly from the battery will be wired into here as well. Once we get these 2 pieces, this one here, finalized just like we did the actual screen, all we have to do left is some wiring, and then we're good to go. So let's actually start getting this mounted in now. All right, so as you can see, what we've actually done here is we've created a recess so that this part of the shunt actually does rest almost flat or directly underneath the actual cross beams here. And so what we're going to do next is create 4 holes so that we'll be able to have small zip ties that will support bracers across the top, that those 2 bracers will actually hold it in place to keep it from moving or flopping or falling out and moving the wiring there. And then that way, when we actually have this upside down, it will hold inside the lid, and our wiring will connect here, which of course will then run to the actual battery beneath. So let's go ahead and get those holes cut. All right, as you see, I'm actually going ahead and just starting these 4 small zip ties. I'm going to do that before I actually begin strapping it down with the cross supports, just so that way if I do end up needing to move this for the time being, it will be easier to manipulate. As you see, it's kind of difficult with some of them as they go down instead of actually pointing back up towards it. Now that we have this down, we're going to center it in. We're going to place one of these cross supports, which should actually end up holding it to it. And we're going to begin pulling the actual zip tie tight. I'm going to move on to the other side. All right, so here it is from the final look, or at least confirming my initial belief, right? So what we have here again, this is recessed, so it's not going to be bending it or putting pressure actually across the top. Realistically, it's going to be supported on the plastic on all sides, just with this third zip tie ultimately holding it tight in place across the middle, held with the two zip ties here on either side. This does hold it quite securely. There's nothing that actually jiggles, or I don't hear any metal movement. If I actually yank on it hard, you can see I can move this here. What I will ultimately do though is, as I begin wiring it in, if I see that there's still movement, I can still cut these smaller ones and re-tighten it to be sure that it will hold well. But this, in combination with the screen on the top, should give us the look we're going for, and also it should give us some cleanliness being able to wire it in this way. The other thing is going to be, which this is a different box bottom, the one that actually has the batteries over on the other side of the table. But the reason I put it down towards the back, as I said, my terminals are on the front, but also with the wiring how it is, as I begin to open the box, once it's fully put together, I won't have to worry about stretching wiring as far, as there's going to be some wires connecting to the screen here, of course, but then also some running into the battery. What this will do is allow me to have shorter wires, or also not have to be concerned about wires coming out so far or tearing one, something of that nature, as if I had the shunt on this side of the box where it would be opening and then you would have a hard time getting the battery in and out, etc. So this should keep everything to the back side, also allow us to actually do the battery. Next up, all we have to do is some wiring. We'll get the actual wires connected. You'll notice it does come with some instructions that shows you will actually have 4 different wires, of course, connected into the housing here. You're going to have 1, 2, and 3 into the actual shunt that go in. The 4th one is actually what's connecting to the positive for power. And then outside of that, you are going to continue to run your loads. Your in or your out load, you can actually run directly into the other bolt of the shunt. And then that's how it is going to actually monitor the power in or out, or the usage for the actual battery, which is where this thing levels you up from an old style battery monitor, or even just a voltage meter like on one of these. Because of how, as I've mentioned before, on a lithium iron phosphate battery, it is a very flat curve. So you could actually be somewhere between 80% or 60% or 40% left of the charge and not know. It could be showing the same voltage here on something like one of these USB voltmeters. But when you actually use something like one of these shunts with the screen, it will tell you how much battery usage you've gone through, and also how many, if you know the size of your battery, it should let you know the actual kilowatt hours remaining. So next step is we're going to go through the wiring, and then we'll be able to test it out. All right, now let's talk wiring. As I was showing before, this is the wiring diagram that's provided. We're ultimately going to need 4 terminals that go directly into the back of the screen or the controller. 3 of those will go directly into the shunt on the left 3 bolts. And then the 4th one will connect directly onto your power. Out from that, any other loads will be running from the load in or out, whichever you choose, and then you'll stack those onto the 4th bolt of the shunt, the farthest right one. So when we see that, what I've already done is I've pulled some connectors together. I will have all of these listed in the description below as far as what I'm using and why. But what you'll see here is these are the ferrule connectors. So what these will do is they will crimp. They will give you the crimped in, and these are the pieces that will actually be plugging directly into the back of the screen. The purpose of using this is you don't have any frayed wires or anything that's going to potentially give you a worse connection or a loose connection over time. You should be able to screw down tight onto this, and it gives you a nice solid connection inside of this, especially because it's on a movable lid. So I do expect it to move a bit depending on which wire is coming out, particularly the one that's going to run all the way here to the positive terminal on the battery, as that's how this will get power directly. After that, what you will see, so speaking of the power side, on this end, what they are is they're the F2 terminals, as we've said in videos before. So what I'm actually going to be using on the opposite end of the power cable is one of these piggyback adapters. So this is where you'll notice it will be connected here. You can have a second connection here. and then it gives the piggyback on the tip on this side. That is what I was actually already using previously. If you notice my two fuse connectors, one of these was going directly into the bottom wire, which connected to the SAE connector. That was for my power input. And then this other one was going right here to the USB out. And so what I had previously was these were just piggybacked together. And so what this will allow me to do is I can just tag directly onto that in a third connection. Again, this might not be the safest thing if you were doing high amperage outputs, but when I'm going to be limited to more or less, pretty much less than 100 watts, I don't expect to really see over 60 watts coming out of that or even going in, because I charge at pretty much 1 or 2 amps. You would see these 3 stacked here, and that will be connected directly onto the terminal. As we step up into bigger batteries or bigger containers, you will leave these F2 styles and you will step into studs. And when you have the studs or just the bolts directly, of course you can stack these connectors much easier, just like we will be doing on the actual shunt. But this should take care of my positive power. We might actually even throw some electrical tape or other type of binding here to keep those from trying to put any additional stress on the connectors. So we will be making up one wire, which is going to be this piggyback adapter and then the ferrule on this side. So that will be for the first one for the power. Next is, you will notice it's going to be a second wire that runs from point number 2 into the large nut or the large bolt here on the shunt, the first one over to that side. So what we will be using here is the correct size that will be working directly for this shunt. I will have that one here, straight into another exact ferrule that will be going directly into the screen. And then for 3 and 4, what you will notice is these are the ones connecting into these smaller screws. So they will be on either side of the shunt, and they will be in the 3rd and 4th spot. And for those, we will be using these smaller adapters, still with a ferrule. So what this will do is this will take care of all 4 of the wires coming out of the screen, and will connect to the corresponding pieces, be it the power side of the battery, the positive terminal, or the 3 spots on the shunt. So now all that will remain is our 4th spot here on the shunt that will connect to any loads. So what I'm going to be doing there is we will have 2 connectors onto the actual bolt. What the 2 are for is, one will be going directly from one side of this to the other end into actually a piece that will connect straight onto the USB adapter or the 12-volt adapter here. And then the second one is going to be coming from my SAE adapter. You'll see it here. And this will plug in directly, again, an F-style connector where they connect together and then also stack. So that way I will be able to actually see the in and the out from this shunt. So now that we have everything laid out and diagrammed out, all we have to actually do is just make it. So now all that we have to do is actually just wire up this massive cords. So unfortunately this does add an extra like 6 cords, but once we wire this up, it will give us much better visibility to what we can see. All right, now that's all the wiring. The one piece that I failed to mention when we were talking about the diagram is you do of course have to have one main negative wire coming from the battery to the opposite end of the shunt from your loads. Because of how the shunt is placed in the negative circuit, what you will find is it has to be able to measure, which is what you're getting on these smaller two connectors. It measures the current between the two, which is how it reads it out on the screen. So what we'll do is we'll get this closed up and then we'll show you the front side of it now that it's actually wired together, and we'll talk a bit more then. So now you can actually see that the monitor is running because it is actually wired in. It does show my voltage here. This is your current amperage that of course is discharging. So this screen does not show the charging current. It will only show a discharge current. Your power in watts, which of course is going to be a calculation between your voltage and your current. And then it will show a calculated watt hours that has left the battery. So this is what's the most important to me, so that I can see approximately how much of the battery has been used when you know how large your battery is. So what you will see if I was to charge this light here, and I plug it into the front, it is a low amperage pool, so it's not going to be a very high watts or amps that you'll see coming out. But as soon as I turn on the front, you will see it begin to light up, and you will see the amperage draw, and then of course the watts, that is the volts times your amps on there. If I leave this running, it will of course increase the watt hours. I have been playing with this for just a bit, so I have burned through some of the battery in here to make sure that the actual watt hours is increasing. And I did test to confirm that it does not either reduce the watt hours spent or increase maximum. Like it doesn't have, call it 100% charge or anything of that nature. It is dependent upon you to know the size of your battery and how much you've used from it. So for the price, it's definitely not bad. But if you spend up into that $50 range, you'll definitely get more as far as a percentage of battery that will show more of like a state of charge beyond just what's actually being used. You can press the button and it will light up in blue. This will stay on until you choose to turn it off. One thing to note is that this will stay on at all times. There is no power switch, and for it to remember how much watt hours have been spent, you do need to have it on at all times. If you were to install a power switch and turn this off, it will forget that piece of it, and you would be starting over from scratch, so there isn't necessarily a memory function here like there is in some of the higher end ones. If you wanted to actually get a state of charge indicator like 100% or that actually tracks both directions, you would need to spend a bit more on a nicer version of one of these shunts with battery monitors, more in the $50 to $60 price range. I think even on Amazon is where it begins. But for the money, it's definitely not that bad. All right, and that's it. Thank you to everybody who's made it here to the end of the video. This shunt and battery monitor is, I believe, $16 or so US. On Amazon, of course, I'll leave a link below in the description if you want to get one for yourself and follow along and make a box like I have. Again, as I mentioned earlier, my big takeaways are, of course, I believe it's worth it for the money just so you can actually see how much discharge has came from the battery. So in watt hours format, it doesn't actually keep track of state of charge or the input, but at least it does track that, which is much more than like the voltage indicator here on the front of the USB. If you haven't already, make sure you hit that subscribe button and follow along for more videos just like this, and we'll see you on the next one.